Thanks for being here today, everybody. So this is kind of an update on, Michael Avalasa and I gave a talk to Nahar, man, like 2 years ago at this point, 3 years ago. So this is some things that we've been had percolating over the last couple years, and also kind of goes through the recent climate change impacts report that ISAS just released last fall. So I mean, the Midwest is like a lot of places. We're, really starting to feel the effects of climate change in a real way. The sorts of changes that people notice in their daily lives. Things like extreme heat, more days over 100 degrees every summer, for example. Things like increased flooding. And these aren't generally speaking, the kinds of like big attention grabbing, headline grabbing changes that you see in other regions, though are generally speaking kind of intensification or, more of things that already happen. So places like the Quad Cities in Western Illinois and Eastern Iowa, yeah, they flood, but they're flooding a lot more frequently and more severely. We expect things like more days with extreme precipitation. I mean, yeah, we do have some of those sorts of things going on. There's some pretty dramatic examples of increased shoreline erosion and rising water levels in Lake Michigan, especially. Uh, so this figure or this map here in the middle actually shows the kind of the remains of an entire neighborhood that got eaten up by the lake over the last 50 years or so. So while those things are happening, they're generally kind of the exception. We're more seeing these slow, incremental kind of gradual onset sorts of changes. And I kind of want to give credit where credit's due. So a lot of the stuff I'm going to be talking about today actually came out of discussions at the 2019 SEAC meetings. So we had a bunch of people from ISAS that sat in on the symposium organized by a bunch of folks on this call. Uh, and that really set off a lot of discussions at ISAS in a big way. There were a couple of things that were pretty immediately clear after seeing those talks. One was that Illinois was behind when it came to thinking about the effects of climate change on cultural heritage. But the second one was kind of a positive. Like, yeah, we hadn't done as much, but we had more time to try and think about the problem and get out ahead of these changes and actually try and mitigate some of the worst impacts of climate change. And I will say
Wow.
we really appreciated the
Oh,
sorts of
boy.
hopeful napkin math by people like Dave Anderson that kind of showed, yeah, the problem is big, but if we can get the right people to care about it in time, it's also a tractable problem we can get out in front of. And so there was a 2021 climate impacts assessment report in Illinois, and it was kind of both a step in the right direction and also an illustration of part of the problem when you're trying to talk about this kind of thing. It's really data rich, it's multidisciplinary. It included people from a whole bunch of different disciplines, sponsored by a big organization like the Nature Conservancy, but it totally left out any discussion of impacts of climate change on cultural heritage. So we saw this and we're like, okay, we're going to write our own report and it's going to talk about archaeology and old buildings. So over the next couple years, we put a lot of work into putting together our own cultural heritage or our own climate change report. You'll notice the title is pretty eerily similar to that Nature Conservancy report. And this one was sponsored by the Archaeological Conservancy. So we got our own conservancy to sponsor it. And a big part of the discussion when we were putting this thing together is who is it for? Is it for other professional archaeologists? Is it for the public? Is it for policymakers? Some combination of all the above. Uh, and the general kind of way it's structured is to try and get people to A, care about the problem. So why should they care about saving cultural resources from climate change? Why is it important to act now? How did people in the past also deal with climate change? So are there some lessons there that we can use in the present? And then how do things like erosion, flooding, and development affect cultural resources, and how might that change under different climate change scenarios? So we really ended up aiming this primarily at the public, policymakers, and then also potential tribal partners. So it kind of took the form of this short, glossy pub with a lot of nice photos. And there's a lot of data and modeling behind that I'll talk a little bit about today, but it's kind of hidden behind this, veneer of nice photos. But really, this was a huge collaborative effort. We had, I think, at least 15 archaeologists from ISAS and other institutions that collaborated on it, as well as a bunch of other folks at University of Illinois and other places, hydrologists, climatologists, modelers, as well as the help of a whole bunch of photographers and layout specialists and copy editors and reviewers. It was a big effort actually to put this thing together. And one thing I'll say, it's, I think, harder to write a good short report like this with, say, 3, 4 page sections and actually say something meaningful than it is to write, 100 or 50 page report. So it was kind of a challenge. It was a little bit outside a lot of our normal, wheelhouse when it comes to writing about this kind of stuff. So like I said, kind of the main chunks of the report. Like I said, this is mostly aimed at the policymakers and the public. So the first section is all about uh, why do we actually care about saving cultural resources, and why should you care about it too? And we're making this argument that sites are important for a number of reasons. Uh, One, they're a reservoir of history. So they offer this deep time perspective on the past that you can't get at any other way. They also are really important for a number of groups, not just archaeologists who, we've got this niche, esoteric interest in the past, but a variety of stakeholders and descendant communities that, really use their ties to the archaeological record, different cultural resources, the landscape, and the past to make claims about access to resources, sovereignty, and identity, and that we should all care about, sites for that reason. The second section kind of goes through uh, the idea that you have to understand the distribution of cultural resources before you can make recommendations about what to do about the problem. So it goes through the distribution of sites and time over time and space. On a real basic level, what can we learn from the past? And then where are the gaps? So where have we done a lot of survey? Where have we not surveyed? So this is just a map of townships in Illinois and then the proportion of each township that's been surveyed. So you have places, up around, say, the collar counties around Chicago or around East St. Louis on the Illinois side of the Mississippi River. Like, we've surveyed tons of places in those areas. But there are other parts of the state that have gotten really very little professional work. So it's pretty important to try and save, unknown sites in those areas before they disappear. So then we just went through, how did people in the past deal with climate change? Whether it's things like uh, rising and falling water levels in Lake Michigan over time, changes in precipitation and heat and drought. Uh, in this bottom map, it's showing the box is actually the region around Cahokia. And the city really expanded and reached its peak at one of the most favorable times in the last several thousand years for maize agriculture. And then only a hundred or a few hundred years later, it slid into this really severe multi-decadal drought. And that had really profound effects on the way the city was organized and how it eventually kind of dissipated. But the core of the report is this set of related models that I want to spend at least a little bit of time talking about. So, like I said, they're all part of this related effort to understand how climate change and other factors are going to affect the archaeological record in Illinois. So the first one is the Illinois Archaeological Predictive Model. So that's a model of where we might expect to run into pre-contact sites in the state. And then there's this set of related models about erosion susceptibility, flood hazard, and then development impact that are all part of this kind of overarching Illinois climate change modeling initiative. So the first model is the Illinois Archaeological Predictive Model. It's a machine learning model that's built using Google TensorFlow. So it uses known site locations, non-site locations, and a bunch of environmental and geophysical variables. It's built a little bit differently than earlier versions that use some Bayesian regression methods. Uh, and whenever you're talking about one of these kind of models, it's really important to keep in mind, like, what's your goal? Do you care about explaining past behavior, or do you care about most accurately predicting site locations? And we really went for the second one. We went for prediction. So it includes a mix of variables that, are probably telling us something about past behavior, and then also ones that probably relate more to things like site preservation or visibility on the surface. And it's not the first predictive model in Illinois. There is a much earlier one that was built about 30 years ago. That's basically just a buffer to rivers and streams. It's a useful model. It kind of clarifies our thinking about where we might expect to find sites. It just turns out not to be a very accurate one. So just sort of in a nutshell, without getting deep into the weeds, basically the model includes a few main bins of variables to predict site probability. You've got, topographic variables, things like elevation, slope, local relief, uh, proximity to good stuff. So things like cost distance to rivers that take slope into account with how costly it is to move across space. Uh, Stuff that's derived from soil data, things like dominant native vegetation or soil type diversity, and then archaeological site locations. So those get fed into a model in R, and then we get predicted site locations or predicted site probability out the other side. And the model turns out to be pretty accurate in testing. It hits 72% of test sites. Obviously, it doesn't hit everything. If you kind of break it down a little bit more, it tends to do really well in sites with diagnostic material, and it doesn't do so well at predicting the locations of non-diagnostic lithic scatters and things like that. Uh, but overall, I think that's pretty good considering this is trying to predict a pre-contact site of any time period over the last 13,000 years. And like I said, we switched methods a few years ago, and the big difference is not necessarily accuracy, it's processing time. So those earlier models would take literally months to run, and the newer machine learning framework takes about 5 or 10 minutes. So it saves my sanity. It makes model iteration a lot more user friendly on my end. So we're taking things like the IAPM and we're trying to match that up with what we know about climate change. So how do, the distribution of known sites, how does predicted site probability, how does that stack up with what we know about things like erosion? And keep in mind, these are kind of, at least right now, models of using current conditions. So either what we've already lost or what we're likely to lose soon. And then we can kind of make some at least general statements about how that might change in the future. And of course, this is not just a problem that archaeologists care about. There's a wide range of stakeholders in Illinois that are affected by something like soil erosion. So just for example, you've got a pretty large percentage of farms in the state are actually losing more soil than they make. So yeah, that affects archaeology in those fields, but it also affects, food security, economics, all sorts of things like that. So we're hoping that these sorts of arguments, you can find tie-ins with a lot of other things, whether that's agricultural, preservation of other kinds of natural spaces, things like that. And there are some, I don't want to make it sound like there aren't dramatic examples of erosion in Illinois. There definitely are. So here's a big erosional gully at the Emerald Mound site in southwest Illinois. You can see archaeologists for scale there in the middle. But this is not kind of typically what we see at most sites in Illinois. At most sites, Illinois or erosion is kind of this slow motion disaster. So you're thinking about losing millimeters of soil a year, not meters. Uh, and a big question that we had is, well, okay, knowing that, what sites are most vulnerable and how long do they have left? So say you've got a site like this where you only have a few inches of topsoil on top of buried house foundations, pit features, things like that. How long does that site have left? Uh, I said this is actually something that Michael and I talked about a couple years ago to Nahar, so I don't want to belabor it too much. But the model we use is kind of a modified version of something called the revised universal soil loss equation. And it's pretty simple. It's basically just an index of erosion variability or vulnerability. It takes into account stuff like rainfall erosivity, so how much rain do you get during a year, and then also how concentrated is it during certain times. How erodible are different soil types in general, how slopey is a landscape, what kinds of vegetation or land cover do you have, and then what sorts of soil conservation practices are in place. And we know, obviously, that last one is really important. A lot of farmers use things like cover crops or contour plowing, grassy buffers around fields. But there's really no comprehensive data for Illinois uh, on where these practices are actually put in place. So we really couldn't include it in our model. We do have kind of some big, large scale data for the state overall. And we actually know that kind of surprisingly, conservation practices are down in the last few years. So, like on average, Illinois farmers are doing pretty good. There's some kind of soil conservation practice used in 61% of farms just a few years ago, but that's actually down to 58% of farms now. So, kind of broad brush, yeah, there's a lot of local variability. You've got, steep, easily eroded slopes that are farmed or don't have, say forest cover are really vulnerable to erosion, not surprisingly. Places like Northwest Illinois or the steep drainages in the southern part of the state. And one thing that was a little surprising to us is that more than 80% of known sites are in areas with high predicted erosion potential. Uh, so, this is, yeah, we have time. Like I said, we're generally talking about millimeters of soil loss a year, but it's something that you need to get out in front of. And if you look at places that have been plowed for a long time, I mean, it's not hard to see why. So this is an example of, it's actually a living history farm that's part of a forest preserve up in northern Illinois. But it's been actively plowed at least since the 1890s, and they've lost at least 25 centimeters of soil in that field. It's a potentially would have been a really cool site. There's actually a small Clovis lithic scatter in that field, but any potential features that would have been there have long since been erased by soil erosion. And a big part of the challenge is like, okay, we've got this index. We can see what areas might be more likely or less likely to erode, but what's the actual measured rate of erosion at sites? There's some places where you can use successive years of LiDAR flights to do elevation change detection over time. So this is Monk's Mound at Cahokia. And so red is actually increasing in elevation and blue is decreasing. So again, the effect that's actually going on here isn't just dirt moving downhill to erosion, it's entire soil packages of the mound get saturated during severe precipitation and actually move down slope as like these rotational slump blocks. So some places we can see it with LiDAR. Other places we're trying to use drone-based photogrammetry, but it's a really technically challenging problem. I said you're talking about really small changes, too small to reliably measure by hand in something like test pits or soil profiles. And you're even kind of starting to push the measurement accuracy of the methods with drone-based photogrammetry. So the hope is that we'll kind of see long-term trends if we monitor these places over a bunch of years. Flood risk is a big problem also. There's, and it's not just pre-contact sites, obviously. There's a huge potential effect, especially on historic standing architecture. So we managed to get our hands on a really, really tasty data set from the First Street Foundation, which is pretty cool because if you actually look on a lot of real estate websites now, things like even Zillow and Redfin are incorporating like a climate risk impact score that's from this First Street data. It includes, so it's got past, present, and future projections that incorporate climate change models. It's got a couple different flood zone depths. And it also includes uh, both kind of overbank erosion and surface runoff. So it's a little more complete than, say, something like a FEMA flood zone map. Uh, and kind of a couple like big takeaways. So one is that, something that actually really surprised us, in this middle chart, the dashed lines are rural structures that are included in the National Register of Historic Places in Illinois. And as a group, rural structures are actually predicted to be much, much more vulnerable to flooding than urban structures. Why that is going to require a little more investigation. I mean, we kind of have some ideas about maybe places in urban areas are a little more buffered from flooding impacts by existing flood control infrastructure. There's probably more funding to protect those kinds of structures, or it just may have something to do with uh, where structures are likely to be documented and registered in the first place. Uh, and how is that going to change over time? So, the predictions between past, present, and future flooding scenarios in this First Street data, they actually don't change that much. And when you look at it in terms of number of structures that are going to be impacted. So like, okay, cool. That's actually a little bit of good news. So things might not be impacted more severely in terms of numbers of structures, but it's not all sunshine and roses. If you look at, say the amount of predicted days with severe precipitation, those are expected to increase dramatically in the next few decades. So while you might not have a higher number of structures that are going to be impacted by flooding, you're likely to have those same structures impacted more frequently. Uh, and what that's going to look like in the future really heavily depends on the climate change scenario, like what road we go down. So if you just compare, say, for example, 2 degrees Celsius warming versus 3 degrees Celsius warming, the number of extra days with severe precipitation doubles with just an extra degree of warming. Okay, and then the last kind of factor that we've been thinking about is future development. Uh, so the population of Illinois has actually doubled over the last century. Whether that rate of growth continues in the future is kind of an open question. Uh, but like I said, inspired by Dave Anderson's napkin math, we kind of did some napkin math of our own. So we looked at things like the recorded density of sites in previously surveyed areas. We looked at, things like predicted site probability from the IAPM and a couple other factors. to try and estimate, well, how many sites does Illinois have? So right now we have about 57, 58,000 recorded pre-contact sites. We've got about 70,000 recorded sites total. If you kind of do the math, it's something like one site per every, depends on exactly how you count it, one site every about 35 or 50 acres. And it comes out with somewhere in between 700,000 to about a million total sites in the state. So if you use that, you can kind of get a gauge on, well, okay, we know about the current boundary and footprint of cities in the state. And you can estimate that somewhere between 50 to 100,000 or maybe 150,000 sites have already been impacted. And most of the time, obviously, impact from development equals destruction. And most of these sites were obviously never discovered before they were destroyed. And our modeling takes into account the fact that uh, as cities grow, they use less new land per person. So we're using census data from 1920 through 2020 to kind of come up with this. So we put together a model. It uses the 1,400 odd populated places in the 2020 census in Illinois. Uh, we feed that into a GIS simulation that takes kind of the modeled predicted size of cities in over an 80-year span. It takes that relationship between, city growth and new land per person into account. And we just go through a couple different growth scenarios. So say cities only grow by 0.5%. Say they grow 1% per year, 1.5%. What does that look like? And we estimate that somewhere between 30 to 85,000 sites, and that's just pre-contact sites, are going to be impacted by development over the next 80 years. Which, I mean, that's a big number. That's basically on scale with the total amount of information that we already know about the archaeological record in the state. And like I said, it's kind of hard. We don't have a crystal ball. We don't know whether current rates of growth in the state are going to continue. Are they going to decrease? Are they going to increase? But we make an argument in our climate assessment that it's actually fairly likely that Illinois' population is going to increase in the future. Like over the last century, we've seen rapid growth, especially in the South and West. And those are the places that are predicted to be the most heavily impacted by climate change. Things like heat, sea level rise, decreases in agricultural productivity, wildfire. So I said, well, it's not certain. We think there's a pretty good odds that Illinois and other parts of the Midwest are going to be recipients of climate migrants as people are leaving other parts of the country. And that's going to put increased pressure on cultural resources as development has to accommodate that new growth. And this is obviously not a foreign idea to archaeologists. People have responded to climate change in the past with changes in mobility and where they settle and how they move around the landscape. So whether that's, rapid warming at the end of the Pleistocene headed into the Holocene, like I said, or changing water levels in places like Lake Michigan. So during the Middle Holocene, water levels actually dropped dramatically in Lake Michigan, and you had huge stretches of new land that would have been pretty attractive. But then at the tail end of that warm, drier phase, water levels actually came up really, really rapidly. We think fast enough that people would have definitely seen it within single lifetimes. Uh, so people respond by moving around. And that's true in the past, it's true in the present. You can look at examples like aridity and soil loss during the Dust Bowl. I'm not like hoping for anything like that in the future, but we know that it's something that people do. So kind of knowing all this, where do we prioritize effort? Just to kind of wrap up. I think obviously places with high predicted site potential and known sites that overlap with high erosion potential or places likely to experience development, those are good places to start. We should also obviously look at places where we don't know a lot about the archaeological record in the state. Illinois is like a lot of places where some parts of the state are really intensively surveyed, other places have received very little professional survey. Overall, only about 3% of the state has been surveyed. Not surprisingly, the oldest sites are really underrepresented in our known sample. So, kind of knowing these basic realities and matching them up with these other sorts of models can help us prioritize what places we need to mitigate first. And I'd also like to argue that kind of positioning archaeology as a public service is a really good way to get people to care about this. So whether that's things like, climate impacts reports, whether that's stuff like public outreach, we have to make ourselves visible and we have to make people understand, why should they care about this problem? I don't think it's a hard job in a lot of respects. It's pretty it's really refreshing and gratifying to do some of these public outreach events and like literally have people say, wow, when they look at archaeology. But we have to get out in front of people and be able to, put in the time so they know about it. And I think we also have to enlist the public and developers as proactive planners in the problem. So just one example, we've put together this free public web app for the archaeological predictive model in the state. Anybody can check it out. So think of it kind of like the equivalent of an archaeological FEMA flood map. Say I'm planning some kind of development, how likely is it that I'm going to impact archaeology in those areas? So the archaeological record of Illinois is already under threat from erosion, flooding, development. But like I said, we have time to get out in front of the problem, and that's a big part of our goal with this is to get people to buy in and put some resources behind more survey, more mitigation, more protection for sites. Obviously, sites are non-renewable, and once they're gone forever, or once they're gone forever. Uh, and while the cultural heritage of places like Illinois is generally not at the center of these kinds of discussions on a national or international level, I think it should be. And I think putting together models like this are a really important step so that, if people come to us for advice, we're ready with evidence-based recommendations. And like I said, this is a really important issue that it doesn't just affect what we as archaeologists can learn about the past. It has a really detrimental effect on people's sense of identity, their link to the landscape, and how they draw that connection between past people and kind of the current landscape. Okay, so that's about all I got. If anybody has questions, I'd be happy to run through anything that anybody wants to see. But thanks.